This is our system of 3 equations, 3 unknowns. We want to find the ordered triple that is a solution for each of the equations. So we need to eliminate one of the variables twice, creating 2 new equations that only have 2 of the same variable. Then we can eliminate one of those to get to our linear equation in one variable, get our numeric answer, work our way backwards to find the other 2 numeric answers for the other 2 variables. I don't like the size of those numbers there. It's going to be some pretty good size multipliers. I think I'm going to go with eliminating x just because the numbers that I have to use as multipliers will be smaller. The least common multiple between 2 and 3 would be 6. Least common multiple, say, between 2 and 5 would be 10. So I can get by with some smaller multipliers if I eliminate x from this system. So let's take equation number 1. Let's take equation number 1 and multiply it by -3. That will make -6x minus 9y minus 21z equals -39. Just make sure -3 times 2x, -6x, -3 times plus 3y is minus 9y, minus 21z equals -39. Let's take equation number 2 and multiply it by 2. That will give us 6x plus 4y minus 10z equals -44 when I multiply equation 2 by 2. 2 times 3x is 6x plus 4y minus 10z equals -44. Now, when we add those 2 equations, the x's disappear, giving us -5y minus 31z equals -83. 9 and 4 is 13, 3 and carry the 1, 3 and 1 is 4, and 4 is 8. So now we have one equation that only has y and z. Let's do this again to create a second equation that only has y and z. Let's work with equations 1 and 3 this time. So this time, with equation number 1, I'm going to multiply it by -5. I'm going to make -10x as that term. So -5 times 2x is -10x minus 15y minus 35z equals, let's see, -5 times 10 is 50, and 50 would be -65. 5 times 2 is 10, 15, 35, 65. I was multiplying by a negative. Those all became negative. Now let's take equation 3 and multiply every term by 2. That'll be 10x plus 2 times 7 is 14y plus 6z equals -56. 2 times 5 was 10, 2 times 7 was 14. Whoops, almost made a mistake there. That was minus z, and I'm multiplying by a positive, so it should be minus 6z equals -56. So easy to make arithmetic errors when solving these bigger systems. That's 0. So here we have minus 1y, and here we have minus 41z equals negative, let's see, 5 and 6 is 11, put on the 1, carry the 1, it'll be 121. So now we can work with this equation and this equation to eliminate one of the variables. Well, I think it would be easier to eliminate the y, wouldn't it? By taking this equation and multiplying by -5. So we -5 times -1y, that's going to be positive 5y. Negative times negative is going to be plus, let's see, 5 times 41. 5 times 1 is 5. 5 times 4 is 20. Equals, negative times negative is positive. Let's see, 5 times 100 is 500. 5 times 20 is 100, so that's 605. If I did my multiplying correctly. which I hope I did. Now let's take that equation, minus 5y minus 31z equals negative 83, and add together these two equations. The y's disappear. What do we have here? 1 from 5 is 4, 3 from 20 is, so we get 174z equals 3 from 5 is 2, and that'll be 522. And 522 divided by 174, I'm sure hoping that's 3. Let's see. 3 times 4 is 12, 2 carry the 1, 3 times 7 is 21, and 1 is 22, 2 carry the 2, 3 times 1 is 3, and 2 is 5. So z equals 3. Yeah, a lot of arithmetic work here. So z equals 3. So now let's plug that value into, say, this equation right here where we only have y and z. So negative 1y minus, putting in 3 for z, 3 times 1 is 3, 3 times 4 is 12, equals negative 121. If I add 123 to both sides, when I get negative 1y equals 2, so y equals negative 2. And now I know that z is 3 and y is negative 2. So if we take z being 3 and y being negative 2, we'd have 2x. If y is negative 2, that'll be minus 6 plus 21 equals 13. And that's 2x plus 15 equals 13. So 2x equals negative 2 when I subtract 15 from both sides. So x equals negative 1. And my ordered triple is negative 1, negative 2, 3. Let's just do a quick check. Yes, my answers on the sheet say negative 1, negative 2, 3. What a miracle. Doing all that arithmetic and not making a mistake. I almost did back there and things would have been disastrous. Tough problems to do without making an error. You just have to try to pay very close attention to detail.